this is the objective, which is to measure the gear tooth thickness by using a gear tooth vernier caliper. And the apparatus which are required for this experiment are a simple gear tooth vernier caliper, a mandrel or a shaft to hold your gear, and a bench center to support your gear and take the readings without inducing any error in the measurement. So this is basically the figures or the real images of gear tooth vernier caliper, and commercially these are available in two types. One is the analog gear tooth caliper and other is the digital gear tooth vernier caliper. And you know the difference between an analog and a digital device. So in digital device you can directly have a reading on this display unit, whereas in case of analog system you have to measure the dimensions manually with the help of your eyes and the help of main scale and vernier scale divisions. So in the construction wise, it is quite similar to a simple vernier caliper. As you can see in this figure, if you remove this upper part, then it will become a straight simple vernier caliper. So the difference in this particular device is the extra part attached over the main scale or frame of this instrument, and therefore it has two vernier scales. One is the horizontal vernier scale and other is the vertical vernier scale. Okay, and these are the screws set your vernier scale over the main scale at a fixed location. This is your analog gear tooth, while this is a digital gear tooth vernier caliper. So the advantage of digital gear tooth vernier caliper, we will discuss it in our upcoming slide. And one of the main advantage, you can say benefit, is to have the direct reading in this particular experiment, and you don't have to calculate anything and you don't have to match the divisions of main scale and the vernier scale. You don't have to multiply it with the least count. It will directly give you measurement on the display unit. You would require a bench center. This is a commercial bench center. You can insert this shaft in the hole given of a gear, and then you can easily mount your gear over this shaft, which can be supported at two ends using these centers attached to the bench center. These are basically 2 or 3 apparatus required in this experiment. In the theory, we will learn what is a gear tooth vernier caliper. Gear tooth vernier caliper is a device used to measure the caudal depth and caudal thickness of a gear tooth in the same operation. So why we have to measure the caudal depth and caudal thickness? Because in a gear there is a variable thickness in the gear tooth. You have to measure the thickness of the gear tooth at the pitch circle. At the pitch point, the majority of the power transfer is taking place. So the thickness at that location is important for all design calculations. So the thickness of the tooth along the pitch line is measured by an adjustable tongue, and this particular device is having two vernier caliper. One is the vernier scale, which measures the depth of the teeth from the top of the pitch line, and a horizontal scale used to measure the depth of the teeth. You measure the caudal thickness of the gear at the pitch point. So you can observe in this diagram, this is schematic diagram of your vernier gear tooth vernier caliper. So these two jaws are used to measure the caudal thickness at the pitch point. This vertical scale, which is having this vertical slide, which is sometimes it is also known as, this vertical slide is also known as the tongue. So this tongue rests on the top land of the gear teeth. Here you have to fix this vertical scale according to the theoretical value of this caudal depth, and then at this pitch point you measure the actual value of the caudal thickness and compare it with the theoretical value of your caudal thickness. So both having the vertical scale and how to measure the reading in the vernier scale, simply you have to match the vernier scale division with the main scale division, and whatever be the zero of the vernier scale where it is coinciding, it will give you the main scale reading. So this is a very simple instrument, but it has a great utility in most gear manufacturing industries. This is a very commonly used instrument for the measurement of tooth thickness. However, there are some other methods you will learn in your metrology subject. So here I will be discussing the usage of this particular instrument, which is your gear tooth vernier caliper. you have to measure the chordal thickness or the thickness at the pitch length of the gear tooth, because your thickness is variable in case of these gear teeth, and majority of the power transmission or motion transmission takes place at the pitch line. So you have to measure the chordal thickness at this particular position. This vertical slide is set to the depth h by means of vernier plate. So the one end of this, what you can say scale, or this is a jaw. This particular slide measures the distance from this lower end of this side jaw to the top line given on the top surface. It gives you the reading of your chordal depth. Once you set this chordal depth according to the design calculation or the theoretical value of the chordal depth, fixing this vertical slide according to that calculated theoretical chordal depth, you have to fix this horizontal slide using this vernier scale and then measure the chordal thickness at the pitch point. We have some formulas which I will discuss in the next slide. You have to compare the value of your calculated chordal thickness with the theoretical value of the chordal thickness. At the end, you have to calculate the error between them. In a particular industry, this error is already defined as per the standard or the client's requirement. If you have the error in that particular range, that means the teeth is acceptable, the design is acceptable. Otherwise, if it is exceeding that particular error range, you have to reject that gear, or then you have to see that it can be reworked, or simply it is going to reject it. That depends upon the measurement or the error which you calculate in your observation. This is the brief theory about the vernier caliper, this gear tooth vernier caliper. And then now this slide shows you how you will measure your gear thickness. As I have told you, this is the sliding vertical slide, or sometimes it is known as the tongue. So it rests on the top land of the gear face, tooth surface. You have to set the chordal depth on this vertical vernier scale. Slowly, with the help of this horizontal scale, you have to slide the jaws and then you have to grip the jaws to capture the chordal width of this tooth, and then you have to compare it with the theoretical value of the chordal thickness. In figure 7, you can observe that with the help of these two scales, there is a adjustment of the chordal depth, and this is the jaw which slides in the horizontal direction. So it gives you the adjustment. Now let's consider the case of a single gear tooth. This is the pitch circle, which is the center of the gear. At some location, this pitch circle is moving in this particular direction. From the top of the surface, this is the H, which is in this diagram you can observe easily. This is the magnified diagram. In this case, this is the profile of your gear tooth, and at some particular location, which is your pitch point. So this is the thickness, which is the chordal thickness, and this is the chordal length of this particular section. And from the top surface to the point of this pitch circle, this is basically your addendum. This H is basically your chordal depth. Now you have to find out the value of W and the value of H from this geometry. You need to calculate the number of teeth, and then you have to know the module. And you know that this pitch circle radius, this is RP, the pitch circle radius, and you know the relation between the module and pitch circle diameter and number of teeth. So from there, this pitch circle radius RP can be calculated, which is equal to the N into M divided by 2. Now you have to calculate this particular angle of this section. This will be the theta angle. How you can calculate the theta angle? So it will be theta angle will be equals to 360 divided by 4 into N. So now 360 divided by N will give you the you can say there is an equal number of division on the gear, on the surface of the gear. In 360 degree there is a equal division, and for this particular quadrant, so if you know that this is one gear teeth and adjacent to it there is a gap which is also having, you can say this is also having the imaginary surface or the tooth of the other gear, and when you want to calculate this particular segment, then you have to divide it with 4, because all the parts are equally segmented. From this geometry, you can calculate the value of W, which is the width. So this W is the chordal thickness, and it is equal to the AC. So this AC, how you can calculate this AC? AC equals AB plus BC, and since AB and BC both are equal, this AC will become twice of AB. Now you have to calculate this AB value. So how you will calculate this AB value? So now you have to consider this particular triangle, which is OAB, and in this triangle this sine theta will be equals to the HAB upon OA. OA is your pitch radius. This is the RP, which is your pitch circle radius. So from here this AB is equals to RP into sine theta. Okay, and this now this this is our theta. So theta can be further simplified into 90 by n. From here you can easily calculate the value of W, which is equal to AC and which is equal to twice of AB. So this theoretical value of caudal thickness comes out to be Nm sine 90 by n. Okay, so this is the expression for your theoretical caudal thickness. Similarly, to find the height, so this is your caudal height, caudal depth, and again in this particular geometry, so this h, if you want to calculate this h, you have to consider this OE minus this is OE and minus OB. So this segment you can easily get, and then OE. So this OE is, what is OE? It is again segmented. This is equal to your this OE is equals to OD plus DE. Okay, so this OD, this is OD plus DE, and from this here you can easily calculate this, what is OE. So OE is nothing, this is OB, and which is your RP, and plus this RP and this M. So from here you have this OE equals to NM plus Nm divided by 2 plus m. This is your equation 2. The first equation, this is equation 1, which is h equals to OE minus OB. From this triangle OAB, what is the value of cos theta? So cos theta is equals to OB over OA, and again this OA is equals to RP. So from here this OB equals to RP cos theta. Then you put this value of RP, which is equals to Nm by 2. So from there OB equals to Nm by 2 cos 90 by n. This is your equation number 3. Now substitute equation number 2 and 3 in equation 1, and then simplifying it, you will get the final expression of the caudal depth, which comes out to be Nm by 2 and whole bracket 1 plus 2 by n minus cos 90 by n. So these are the expressions you have to. So anytime you have to calculate the caudal thickness and caudal depth, then these formulas are very important. And after this, what is the procedure? So once you have the theoretical value of caudal depth and caudal thickness, it's the time to measure the actual value of the caudal thickness. So to start with, the following data is required. You require number of teeth, which you can easily count, and then sometimes if module is known to you, then it is, sometimes this module is already calculated in the design calculation. If it is not there, then module can be easily calculated by this expression, where d naught equals to m into n plus 2. So where d naught is the outside diameter or the tip diameter. From there you can easily get this value of m, and then put it in the value of this as theoretical. So as theoretical, what was it? It was as theoretical. So this was Nm by 2, 1 plus 2 by n minus cos 90 by n. So here, suppose if you have 40 number of teeth and module is it's 1.2 or 2, then you put all the expression here and easily calculate the value of h. So h will be your theoretical value, and then you have to set it onto the vertical vernier caliper. So now suppose it is some value of 2.125, it is going to be difficult for you to set in the analog device, but in case of the digital vernier caliper, so the setting is comparatively easy. So that's the benefit of the digital vernier caliper. And then testing your sliding lag or the tongue over the top surface and setting the theoretical height, you measure the caudal thickness, which is your W actual. This is the W actual at the pitch circle, and in the final stage you compare the W actual with the W theoretical, which you have calculated. What is the W theoretical? This comes out to be Nm sine 90 by 9, this Nm sine 90 by n, and then you report the error. This is the kind of result summary chart you have to prepare, and then you have to take at least 5 to 6 readings on different gear tooths, and then you have to take the average, and then you have to check the average error. This will be your W theoretical, and this value will be fixed for all the readings, whereas this will be varying. And then finally you will have the error, and then you can calculate the average error. So this is all about the procedure of this very simple instrument. With the help of this instrument, you can calculate the thickness of the gear tooth. The most important thing is to take the readings in a very precise way. You have to mount your gear on a proper shaft, and then you have to fix this shaft in between the centers of a bend center. So sometimes they keep this gear in their hand, and then with the help of the gear tooth vernier caliper, they try to measure thickness. This is not the proper way. Good engineering skills, this practice, what you have to do, you definitely require these things like a proper mandrel to mount the gear, a bend center, and a proper digital caliper. The digital vernier caliper should also be calibrated so that it will have a minimum or no error. Otherwise, what will happen if it is not calibrated, with the course of time the jaws of the caliper degrade or worn out? That will cause some error or the mismatch in the zero of the main scale and zero of the vernier scale. With that faulty instrument, if you want to take out, you want to measure the gear tooth thickness, then it will give you error. And before taking any error or measurement on the teeth, your gear should be thoroughly clean. So for that purpose, you should use some solvent or cleaning agents which are commercially available in the market. And simplest is the use of ethanol, so you can easily remove all the dust and grease from the surface. Even and same applies to the gear vernier caliper. All the jaws should be clean and free from rust and dust. With the proper attachment and mounting of your gear on the shaft, you can minimize the error. These are some precautions which you have to take care while performing this experiment. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.